Today we will be working on lesson 26. Please take out your light purple problem set book and follow along as I explain these problems. Looking at A, the problem asks us to plot the following points on the number line without measuring. So, if we look at our first number, we have 2 and 7/8. So we're going to start at 2, and then we have to imagine that between 2 and 3, it's broken into eighths. So for visual purposes, I will show you what that would look like. Now we have 8 pieces. So if we're plotting 2 and 7/8, we would go to the 7th line, and that is where we would plot 2 and 7/8. The next fraction that we have to plot is 3 and 1/6. So we start at 3, and then we imagine that between 3 and 4, it is broken into 6. Now we need to go to 3 and 1/6. So I go to the first line that I made, and I mark 3 and 1/6. For our third fraction, you can see that we have 29/12. Before we can plot this on our number line, we need to first convert it to an improper fraction. So you can either use the strategy that we learned yesterday about number bonds, or you can divide, whichever you prefer. You can see from my work that I converted 29/12 into 2 and 5/12 by first pulling out 24/12, which is equivalent to the whole number 2, and then you take 29 minus 24, and you are left with 5/12. When you combine them, you get 2 and 5/12. Now I need to plot that. So I go to 2, and now I need to break it into 12 pieces. Now that I have divided this into 12ths, I will select the 5th mark. This is where I will plot 29/12. The next problem is asking us to use the number line to compare the fractions. So for I, it says 29/12 and 2 and 7/8. So we first look to 29/12, and we see that it is less than 2 and 7/8 because it is closer to the left side of the number line. So we know that 29/12 is less than 2 and 7/8. Next, it directs us to 29/12 and 3 and 1/6. We know that 29/12 is also less than 3 and 1/6. Let's try the same thing with different fractions. Now we are starting with 70/9, so we need to convert that to a mixed number in order to place it on the number line. You can see from my work that I converted 70/9 into 7 and 7/9 by taking 63/9 or 7 out, and then what remains is 7/9. So we get 7 and 7/9. If you would prefer to do this by dividing, that is completely fine. So you could say 9 goes into 70 7 times to get 63, and you subtract to get 7. When you go around the clock, you end up with 7 and 7/9. Now we need to look to our number line, and we will start at 7, and then we will divide the space between 7 and 8 into into ninths. Now that I have divided my number line into ninths, I will go to 7 and 7/9, and that is where I will mark 70/9. The next point that we are plotting is 8 and 2/4. Before I start, I can simplify this mixed number into 8½, which is much easier to visualize as you're plotting on the number line. We can start at 8, and we can just go halfway in between 8 and 9, and that is where we can mark 8 and 2/4. The next number that we are plotting is 25 thirds. So before we do that, we need to convert 25 thirds into a mixed number. I'm going to do this by dividing. I know that 3 cannot go into 2, but it can go into 25 8 times. 8 times 3 equals 24, and I subtract to get 1. I go around the clock to get 8 1/3. So I will now plot that on my number line. I go between 8 and 9, and I need to divide my number line into thirds. I go to the first line, and that is where I will plot 25 thirds. Now, we know it's going to come before 8 1/2 because we know 1/3 is less than 1/2. Now we will use the number line to compare the following fractions. I want you to pause the video and try this on your own, and then push play and check your answers. You should have answered that 8 2/4 is greater than 25 thirds, and 70/9 is less than 8 2/4. You do not need to do C. Now you will practice comparing mixed numbers and improper fractions. You do not need to use the number line as you continue to do this. When comparing mixed numbers and improper fractions, convert the improper fractions into mixed numbers before comparing. In our first problem, we have 5 1/3 compared to 4 3/4. We know that 5 1/3 is greater than 4 3/4 because our whole number of 5 is greater than our whole number of 4. For B, we need to convert our improper fractions into mixed numbers before comparing. For 12/6, we know that we can pull out 6/6 and 6/6 to get 2. For 25/12, we know that we can pull out 24/12, which equals 2, but we're still left with 1/12 to get 2 1/12. So 25/12 is greater than 12/6. We are comparing 18/7 and 17/5. We need to first convert these improper fractions into mixed numbers. For 18/7, I can pull out 14/7, or 2, and I am left with 4/7. So our new number is 2 4/7. For 17/5, I can pull out 15/5, or 3, and I am still left with 2/5. So 3 2/5. So 2 4/7 is less than 3 2/5, or 18/7 is less than 17/5. Please take a second and think about why it's easier to compare mixed numbers than improper fractions. When comparing 5 2/5 and 5 5/8, we're going to practice finding our common denominator. So we're going to forget about our 5s for now, and we're just going to look at 2/5 and 5/8. Our common denominator for these numbers would be 40. And remember, this means that both numbers can be multiplied by another number to equal 40. So when looking at 5, to get from 5 to 40, we multiplied by 8. So we need to do the same thing to our numerator. 2 times 8 equals 16. When looking at 8, we multiplied by 5 to get to 40. So we have to take 5 times 5 equals 25. So our new mixed numbers are going to be 5 16/40 and 5 25/40. We know that 5 16/40 is less than 5 25/40. For E, we are comparing 6 2/3 and 6 3/7. I want you to pause the video now and find a common denominator for 2/3 and 3/7, and then create an equivalent fraction using that new denominator. You should have found a common denominator of 21. When you created your equivalent fraction, you multiplied 2/3 by 7 and 3/7 by 3 to get 14/21 and 9/21. When you compare 14/21 and 9/21, you know that 14/21 is greater. That being said, 6 2/3 is greater than 6 3/7. Please try F on your own now. Pause the video and then push play when you are finished to check your answer. You should have converted 31/7 to 4 3/7 and 32/8 to the whole number 4. So you know that 4 3/7 is greater than 4. That being said, 31/7 is greater than 32/8. Please try G on your own. Pause the video and push play to check your work. When you converted your improper fractions to mixed numbers, you should have converted 31/10 to 3 1/10 and 25/8 to 3 1/8. Using what we know about comparing fractions with like numerators, we know that the fraction with the smaller denominator will be greater because the pieces are bigger. So we know that 3 1/8 would be greater than 3 1/10. That being said, 25/8 would be greater than 31/10. Please attempt this problem on your own now. Pause the video and push play when you are finished to check your work. You should have converted 39/12 to 3 1/4 after simplifying, and 19/6 to 3 1/6. Once again, we have like numerators. So the fraction with the smaller denominator is greater. So 4 is less than 6. So 3 1/4 is greater than 3 1/6. That being said, 39/12 is greater than 19/6. When looking at 3i, we don't even need to convert because if we just look at this problem, we can see that 49/50 is a proper fraction, meaning that this fraction is less than 1. Over here we have 3 and 90/100, which is greater than 1 because we have the whole number of 3 and then another fraction. So we know that 3 and 90/100 is greater than 49/50. For J, we do not need to convert either. We can look at this problem and look at our fractions. We can see that 5/12 is less than 1/2 because if we're working with 12s, 6/12 would be the 1/2 mark. If you look at 51/100, if we're working with 100s, then 50 would be the halfway mark and 51 is greater than 50. So we know that 5 5/12 is less than 5 1/2, and 5 51/100 is greater than 1/2. So we know that 5 5/12 is less than 5 51/100.